Hello everyone, my name is Sandra Gonçalves. I will present a paper entitled Data-Driven Disaster Management in a Smart City. This project was developed in partnership with the Lisbon City Hall, and it was born in the context of the city's transformation into a smart city. This transformation involves several aspects, and the implementation of a disaster management system is one of the main dimensions to be considered. In this way, the core objective of this study is to analyze data about incidents that affect the city of Lisbon in order to extract insights that can help agents in the process of developing disaster management strategies. To conduct this study, two datasets were used, which were provided by the Lisbon City Hall. The first dataset corresponds to occurrences registered by the Lisbon firefighters, and the second dataset is regarding to data extracted from the application called Na Minha Rua LX, which is an occurrence management application. The analysis was conducted on two levels, where in the first step, a general analysis of all types of occurrences reported in both datasets were carried out, and in the second moment, the analysis focused only on occurrences that affect buildings of the city of Lisbon, and for this level of analysis, specific objectives were defined for each dataset. In case of the firefighters dataset, the following objectives were defined. There is the identifications of the occurrences reported, their analysis from a temporal and spatial perspective, and finally, the applications of predictive models to predict the occurrences. Regarding the dataset with the data from the application, the objectives defined were the characterizations of the reported events, and their analysis from a temporal and spatial perspective. The methodology used to conduct this study was the CRISP-DM methodology, which is a standard methodology in data mining process. This methodology includes 6 phases, namely business understanding, data preparation, modeling, evaluation, and finally the deployment. Regarding the state-of-the-art, a systematic search was developed in 2 electronic databases, namely Scopus and Google Scholar, in order to identify documents that have been published related to data-driven disaster management in the context of a smart city. To this end, a query was created with the following keywords. Regarding the documents typology, only journal articles, conference papers, books, and book chapters were considered, and additionally, a time window of 10 years was defined. The result showed that most of the papers were published in China, and there is an area that has gained relevance due to the increasing number of publications in recent years. And the results also showed that the studies cover both natural and man-made disaster. And in case of natural disaster, there is a predominance of flood case studies. And in the case of man-made disaster, there is a predominance of fire case study. I will now present the results obtained by the applications of the CRISP-DM methodology to the firefighters datasets. And the first general analysis showed that the firefighters respond to several types of occurrences, and there is an overlapping category, namely the services category, which presents a proportion of 45.7% in the whole dataset. This category includes services such as road cleaning services, hospital transportation, and patrolling services. Moving on to the second level of analysis, that is the analysis of the occurrences that affect the buildings in the city of Lisbon, it was found that they are the following types: collapses, floods, suspicious situations that include verifications of smoke or smell, accidents with equipment or elevators, fires, and gas leaks. This bar chart presents the temporal distributions of these 6 types of occurrences over the 12 months of the year, and it was found that the case of collapses, floods, and suspicious situation presented in figures A, B, and C have a higher incidence in the month of autumn and winter. The cases of gas leaks represented in figure D stand out the month of January. The case of accident with equipment or elevators represented in figure E stand out the month of July. And finally, the case of fires stand out the month of December. Given that it was verified that certain types of occurrences have a higher incidence in the autumn and winter month, the influence of the precipitation on the incidence of these occurrences was verified, and in this sense a segmented approach was adopted where the dataset were divided according to 4 levels of precipitation, that is, when the precipitation is 0, when the precipitation is low, when the precipitation is moderate, and when the precipitation is heavy. And the results showed that cases of collapses and floods increase when the precipitation level increases, and it is noteworthy that the case of fires, since when precipitation is 0, the flood case represent a proportion of 4%. With the low precipitation level, this value is 19%. With the moderate precipitation, the proportion is 47%, and when the precipitation is heavy, this proportion increases to 73%. A geospatial analysis of the occurrences was also made through the elaborations of heat maps, and it was verified that the central zone of the city of Lisbon is the most affected area. And since the central area of the city is the most affected, analysis was done in order to deepen the knowledge about the buildings in the city by analyzing the proportion of degraded buildings and the average age of buildings per parish. And with this in mind, heat maps were created with the spatial representations of the proportions of degraded buildings or in major need of repairs, and the spatial representations of the average age of building per parish. And from these 2 heat maps, it was possible to verify that it is in the central area of the city where the oldest and the most degraded buildings are concentrated, constituting an area more exposed to risks. I will now move on to the presentations of the results obtained by the applications of the CRISP-DM methodology on the dataset with data from the application. And the general analysis showed that the occurrences reported are of 4 types, namely illegal construction, degraded buildings, wall, scarp or slope, inspections of insalubrity, and illegal occupations of buildings. And when analyzed over the years, results showed that cases of illegal constructions are always reported in greater proportion. Regarding the second level of analysis, a temporal analysis of the type of the occurrences reported was analyzed, and it was found that cases of illegal building of the illegal occupations of the buildings have a higher incidence in the month of May to October, and cases of degraded buildings have a higher incidence in the last 4 months of the year, and also in the month of March, May, and June. A geospatial analysis was also conducted And similar to the case of the firefighter dataset, it was found that it is the central area of the city the most affected area by the occurrences. Regarding the prediction process, predictive classification models were applied in order to predict the occurrences of the firefighters dataset, and the results showed that the random forest algorithm performed better with an accuracy of 58%. The adopted methodology presupposes the evaluations of the project, and for this reason, after presenting the results to the people responsible for the project, a satisfaction questionnaire was applied in order to assess whether the work developed is in accordance with the defined objectives. And in this way, criteria such as utility, clarity were evaluated, and the criteria had 4 possible evaluation, that is not achieved, partially achieved, largely achieved, and totally achieved. And the assessment given to the criteria were mostly partially achieved and largely achieved. To conclude, the research developed in this study showed that the advances in the IT area have positively impacted the area of disaster management, since the development of strategy can be based on analytical results. And in this case, in this case in particular, the analysis allowed to extract knowledge about the temporal patterns of the occurrences, as well as the identifications of the areas with higher incidence, having been concluded that it is in the central area of the city the most affected, being the area with the greater proportion of old and degraded buildings. As future work was identified a more detailed analysis of the occurrences by relating them to the state of conservation of each building, the addition of more external information such as the type of material of the construction and the year of the construction, and also the number of abandoned buildings. And finally, the applications of other predictive models in order to improve the predictive results was also identified as a future work. Thank you.